Imagine there is a pulley here. And around the pulley, we have a cable. On the left side, this cable is connected to a block. On the right side of the cable, which is here, I want to pull it downward. Imagine this is my force on the right. An example, I don't know, 200 newtons, for example. But it's not important. I want to focus on the left side. This one is important, and this is my point. The mass of the block is M. And this is your block. I'm sorry, this is your pulley. You can have rotation for this pulley if you apply a force on the right side. Okay, draw the free body diagram for this block. At first, you should separate it. You have to separate your block for every case. This is your mass, or this is your article. Okay, the first one, you know, you have always weight force. Downward, that's W. What is next? Do you agree the cable, which is on the top of the block here, it can generate a force, and this force causes upward motion for the block. The force which is inside the cable, or the force which is inside a string, it is called tension. Therefore, this is next force. It is on the top, and the direction is upward. That's T, capital T, called tension. Consequently, over here for your block, there are two forces. Next one is friction. Friction force. Imagine there is a block here. I'm going to apply a force as an external force to the right. That's F0. But here, you don't have a smooth surface. And if you don't have a smooth surface, it means you have friction. The friction is a kind of resistance, which is against the motion. Consequently, at the bottom of this block, you have second force. Actually, The first force is weight, the second force is F0, and the third force is friction. Friction force exists when you have a surface which is not smooth. At that moment, you have resistance from the surface applied on the block, and it is always opposite to the motion. Therefore, let's plot it. Separate this block. This is your block. So you have mass, it means you have weight force. Downward. W. Second factor is external force to the right, F0. What is next? At the bottom of the block, you have friction force because of the surface, because of this surface, which is not a smooth, and it is to the left. It is against the motion of the block. Like this. It is F of F. F of F, friction force. It's here. Sometimes you have complicated system. Imagine you have a system which includes many forces, or maybe you have many blocks. At that time, you have to focus on each block separately and separate it. And you have to take that block and focus on it. Apply all of forces on this block with respect to its condition. Okay, I'll show it to you here. Look at this system. Imagine there is a block here. I'm sorry, there's a pulley here. And we have a cable. And there are two blocks here. The first block is on the left side. It has first mass, like M1. And the second block on the right side, that's heavier, like this. That's M2. Imagine at first, they don't have any velocities. If I want to release these blocks from this position, do you think what happens? Of course, heavier block will go downward and the lighter block will go up. It means you can have motion. And you can draw the free body diagram for each block. Let's do it. Focus on first block, I mean M1. First block. weight force down. You know, this is first weight force. In other words, it is W1. What is next force here on this block? Obviously, on the top of the block, you have a cable. It means you should have tension. That's upward. Okay, add it. That's T. Focus on the right side. You have block number 2. For here, this is your second block. Obviously, you have W2. What happens to the cable on the top of the block? If you have a uniform cable around the pulley, at that moment, the tension on the left side equal to tension of the right side. It means you have the same T here on the right. Therefore, put an arrow here, like tension for the second block, and it is upward, and you have the same value. That's T. I mean, you have T on the right, and you have T on the left. They're the same. If there is no friction for the pulley, and if there is no mass for the pulley, at that one, we have this condition. I mean, you have the same tension for both sides. Thank you.